So just realize that the scope of the languages we're about to learn is actually fairly narrow. So here's a little program that we saw last week. When green flag clicked, say, oh, hi, world. Something to that effect. So this was a script. The purple piece there was a statement. And statements, again, just do something. Well, just to kind of tease you with how we're going to start translating what's very user-friendly and very sort of graphical and playful into something that's a little more easy for a machine to understand. Starting today and beyond, if you want to write a program that just says something silly like, oh, hi, world, you're actually going to type in a text editor, like Notepad or TextEdit, whatever, or more fancy programs that we'll introduce, something like this. Int, main, void, some curly braces, printf, and we mentioned printf last time, and oh, hi, world. So there's some crazy syntax in here, semicolons, curly braces, things that take a little getting used to, but you start to see these things recurring. So when you start to see code like this today and beyond, just realize, it's really just Scratch. It's really just those two puzzle pieces we saw last week. But the syntax now is a little more cryptic. It's not nearly as user-friendly, but you get good at it, I dare say, quickly. So statements in general. This was a statement, oh, hi, world. This would translate more directly just to this one line of code. So when we say things like code and source code, programming code, any of this sort of jargon, we're talking about lines like that. And in most programming languages, when you want the computer to do something, you express it in the form of a line of code. And sometimes the line gets a little long, but in general, one line means do something, just like one puzzle piece means do something. Well, what about loops? Last week we saw something like this. Forever say, oh, hi. It's just going to say this and say this and say this and say this. The syntax this week and beyond is going to look a little more cryptic, but we can express the same idea. We're going to have a keyword called while. We're going to have kind of a stupid structure here where we say while true. And then in the curly braces, we're just going to say printf, which, as you can kind of infer, means print this to the screen. And what are we going to print? Oh, hi. Now, while true, why is this equivalent functionally to forever? Well, true is always true. So it's just as though you're saying do this again and again and again, because there's no variable there. There's just what we'll call a constant, the keyword true. And it's like saying while one, while one, while one, while one. One is always not 0, which means it's always true. So again, one and true and yes are all synonyms for our purposes thus far. Well, what about loops like this? Repeat 10 times, say, oh, hi. Well, we need a slightly different construct because while true kind of implies an infinite loop. But there's this syntax in C called a for loop. And again, we'll come back to this. This doesn't all have to sink in now. But you say something like for int, and int's going to mean integer. Int I is going to be a variable. So set I equal to 0. Then do this loop so long as I is less than 10. And every time you do something, go ahead and increment I with plus plus. So there's going to be shorthand notation like this, plus plus, which just means increment. Add 1 to a variable. And we had a puzzle piece quite like that in Scratch. Add 1 to some variable puzzle piece. Well, variables in Scratch looked indeed like this. Set counter to 0. Forever, do this. Say counter, change counter by 1. So this should just say 1, 2, 3, 4, 5, 6. Infinitely long. How can we implement that in C? Well, we need a variable. So it's going to look like this. Int counter gets 0, or equals 0, while true. And now we kind of steal some syntax from previous examples. The printf, the plus plus. But the idea is the same. So again, even had we shown you the text in white in the first week, it's kind of overwhelming. It's kind of confusing. It's not all that intuitive at all. But the ideas are exactly the same. And this is why we start with Scratch, because it gets across the ideas without the stupid distraction of what's ultimately some arbitrary syntax that humans decided on that we all just need to acclimate to. But we will, and quite quickly. So Boolean expressions. Boolean expressions were what? How do you define them? Yeah, so true or false, something that's yes or no, 1 or 0, true or false. So they looked like this in Scratch. Is x less than y? Is x less than y and y less than z? Well, we can do the same sort of expression in C. We use some parentheses. We use some angled brackets, but it looks like this. X less than y, or is x less than y ampersand ampersand. And ampersand ampersand happens to represent the notion of Boolean and, like the anding things together. It's distinct, as we'll see, from a single ampersand. So there's some oddities like that, but it's the exact same idea. So we can do a few others with conditions. We had something like this. If x is less than y, say x is less than y. Else, if, so remember we could embed one puzzle piece in another to have multiple forks in the road, not just one or two or three. We could keep doing this. Well, we can do this in C as well. In this case, I'm essentially saying if x is less than y, then say as much. Else, if x is greater than y, say as much. Else, say they're equal, because that's the only possible alternative if it's neither less than nor greater than. So it translates to this. If x less than y, curly braces, printf. Else if x greater than y, printf. Else, printf. And the curly braces kind of, just like the if conditions and the else conditions in Scratch kind of have these embracing yellow bars, similarly do the curly braces conjure up that same idea. It's enclosing one or more statements inside of them. Well, what about arrays? We only talked briefly about these. Maybe you've deployed them in your own program. But an array is what in English? Yeah, it's like a list. It's some kind of data structure, data storage. It's a container in which you can put 0 or more things. This is in contrast with a simple variable, because with a variable, you can just put one thing. So if you wanted to store, like in the game Fruitcraft RPG, which we played briefly last week, if you wanted to collect the apple and the orange and the pear and whatnot, you could have an apple variable, an orange variable, a pear variable. But your program very quickly gets bloated with all of these darn variables, all of which are related, and yet you need to sort of independently define them. An array lets you say, I need multiple such fruits, and I want to keep them somehow together in sort of one bigger variable, but still get at individual components as we did with the Fruitcraft RPG. So how do we translate this to C? It takes a couple lines this time, but add orange to inventory might map to something like this. String inventory bracket 1. And we'll come back to this next week, but string is synonymous with word or phrase or sentence. It's some number of characters that a human might type. Inventory is just the name of this variable. And the bracket 1 probably denotes what? Yeah, the size in this case. And we'll see this is kind of a stupid array because I'm only storing one thing, but it's meant to be a simple example. This just means give me an array of strings, of words, of size 1. So again, it's stupid in that I could just use a single variable for this, but we could just change that 1 to a 2 or a 10 or a 100, and that little character on the screen could then collect 2 or 10, 100 pieces of fruit. It wouldn't necessarily be bounded by 1. And then inventory, open bracket 0 equals quote unquote orange. We'll see next week. This is just the way of saying put the string, the word orange, inside of location 0 in the inventory. Now here we see one of the first curiosities of computer scientists. Turns out computer scientists, programmers more generally, typically count starting at 0. Why? Well, if you think about our discussion last week of bits, and even just now, what's the smallest number you can represent with a bit? Well, 0. What's the smallest number you can represent with 8 bits? 0, just 0, 0, 0, 0, 0. So why not just start counting at 0? Why waste this bit arbitrarily like humans do in speech, counting at 1? So in general, it's just easier, and it's definitely conventional to start counting at 0. Thus was born problem set 0. Thus was born week 0 last week, and so forth. We've just preserved this same tradition. So Scratch, however, does not do this, realize. They made a pedagogical decision, particularly for the target audience, to actually start counting most things at 1. So realize this is not universal, but it is quite common.